Dear students, welcome to the interview for Lecture 5 of our course. We have with us today Professor Nakicenovic, and he's here to answer a few questions for us. Okay, so I'm going to start with the question of if investment requirements are only 50% over business as usual, why are we not already investing, and why is this posing such a challenge?
Well, thank you very much for this question. Actually, I think this is a very pertinent question, because one would assume that with the 50% more investment, that's roughly in the range of what we are already spending on subsidies for energy, we would have enough capital to achieve the transformation, but it's not happening. And I think it's a kind of a paradox, if you wish. One of the major reasons why we do not see this investment forthcoming is because we would need business models. Today, the financial sector, when one invests in something, expects to have very fast returns. Within 3 or 4 years, technology has to pay for itself and has to show to become profitable. Now, these technologies are also profitable, the renewable energy efficiency as well, but you need a little bit longer time. So one has to be there for the long haul, and I think our markets are not there for the long haul. So we have a little bit of a mismatch between what the social needs would be, the transformation that would benefit everybody and reduce the cost in the long run, and the fact that in the financial sector one wants to make relatively fast profits. And this is, I think, a big barrier. So for that we need institutional change.
Yes, there's a bit of a contradiction there then.
Yeah.
Yes, okay. So in one of the first graphs you showed us with the population rise through the agricultural period to the industrial period, I noticed that in the last period the graph appears to be quite flat, although we know that the population has risen vastly in the past 200 years. So I was wondering why it looked this way.
Yeah. Well, you said appeared, and I think that's the key word. It appears to be growing slower, and to an extent this is an artifact of the way I've shown the graphs. I've mentioned in the lecture that it's shown on double log. Vertical scale is logarithmic and horizontal scale is logarithmic. Now, in reality, if I was going to plot that on a linear scale, I would need a graph that's meters and meters long to show the last million years of human history. But on that kind of graph, it would look exponential all the way through. And just to illustrate that, so from the beginning of humanity, of Homo sapiens, let's say a million years ago, to about 10,000 years ago, we went only up to 6-7 million people in the whole world. And then from the Neolithic Revolution, so-called Neolithic Revolution, 10,000 years to just 200 years before the present, over that period, the global population grew to 1 billion. So that's a huge increase, 100,000 times it has increased. And that's exponential. But then acceleration is even larger. During the last 200 years of the Industrial Revolution, we went from 1 billion to 7 billion. And so that's almost astronomical. And now we are somewhere to the inflection point. From now on, if everything goes well, birth rates will be going down, in particular in developing countries. Here they're already relatively low, so that the population growth will slowly level off and peak at about 9 billion in 40 years. So the answer to your question, it is indeed exponential. I've chosen just the graph presentation so that I can show the deep history to see how low the population was in the previous era of human development and how fast this growth was from 1 to 7 billion in just 200 years.
Okay, yes, so we hope that will stabilize eventually. Great. And I also noticed that you referred to this great transformation as the decarbonization revolution. And I see that these things are sometimes referred to as transformations and sometimes referred to as revolutions. And I was wondering what you would say the difference was.
Yes, I think in fact one has to be a little bit careful with the language, because when we say revolution, very often you think about big upheavals, crowds in the streets, shooting and fighting, abolishment of the systems, and those things are true revolutions that happen often in a short period of time, but then the period afterwards can be long. And so here it's more symbolic. It's an analog in this context. We're talking about a grand transformation transforming the society, and we are saying that's going to be a revolution, but I don't think we really mean it's going to happen in such a short period of time. It's, I think, that will stretch over decades, so I think the coming transformation will also last decades. But it also has another element of revolution in it that I would like to highlight. It's not going to be smooth. Not like the S-shaped vision I've shown you, that green curve in one of the slides in the lecture. It's going to be phases of prosperity interlaced with the phases of depression and stagnation. So in that sense also it will have some elements of the revolution. But I think that the correct word is the transformation, but we are using the word revolution also to designate the emergence of agriculture, as I've shown in that graph that we talked about, emergence of agriculture and emergence of the industrial society.
Okay, yes. We talk about extending access to people who are living in energy poverty currently. This is obviously a very important factor, and I was wondering if this would make the energy transformation more challenging, if we have to make sure that the way that they get access to energy is also sustainable.
It is more challenging in the sense that we are really talking about two transformations. Yes. The 3 or 3.5 or 4 billion people that do have adequate access, or at least semi-adequate access, they have to decarbonize. But people who do not have the access first have to have access. And in some cases that might even mean going to fossil energy. LPG for cooking is better than traditional biomass. It would have lower emissions, in particular indoor, and indoor pollution is a big problem. So that's it's a double transformation. But what I would like to emphasize from my point of view, and I think that's also in the Flagship Report quite clearly described, is that this is perfectly consistent with efficiency and decarbonization trends. People who do not have access cook with traditional fuels. That's very inefficient. So providing and making efficient stoves would both be a health benefit, would be a benefit for development, but most of all, it would be also an efficiency benefit. That would reduce the emissions of particulates and many of the other substances that are also active climate substances. So it would even have a climate benefit. While it is true, though, that by empowering development through access, one would have economic growth, that would require more energy, that is all true, might lead to also higher emissions. But that's what we want, actually. In this case, this is what we want. We want the development, and once that's achieved, then the transformation that's happening in more prosperous parts of the world, more affluent parts of the world, can occur there as well. So I see it as a holistic approach of one grand transformation.
Okay, so all interlinked then. You said that when burning coal and gas, a lot of the CO2 emissions are washed out in the oceans, and I wanted to ask what kind of effect this was having on the planet also.
Yeah, it is increasingly evident that it has effect as well. So much of the exchange of carbon occurs between the atmosphere and top layers of the ocean, but of course also with the biosphere. In the fall, when the leaves decay, carbon dioxide is released. In the spring, when you have growth, carbon dioxide is absorbed from the atmosphere. But the oceans have taken up the brunt of the additional carbon that we have emitted. In the lecture I talked about 1,500 billion tons of carbon dioxide that were emitted. About half of that stayed in the atmosphere. The rest went in the top layers of the ocean and the biosphere. Now, carbon dioxide is an acid when dissolved in water. I mean, that's like Perrier or mineral water with gas. That's acidic because it has CO2 in it. And so that's what we have been doing to the top layers of the ocean, and eventually to the whole ocean. We are increasing acidity. That can have really serious negative impacts on the ecosystems in the oceans. Let me say, this is not my area of expertise, but everybody has read about the coral reefs and many other negative environmental impacts of that. So it is not just a change in temperature. Change in temperature is a kind of I think a symbol for many, many other planetary changes that the increased carbon dioxide emissions and greenhouse gas emissions are causing.
Okay, thank you. So this supergrid is going to help get energy from one place to another from not urban areas to urban areas, and even from country to country. So I'm gathering that the scale of this is going to be very massive then.
Mm-hmm. Yeah, supergrid and in general grids. I mean, we don't immediately have to jump to a supergrid. That would be kind of a future vision. But we need grids. And I think one way to explain the possibility of having ever larger role of renewables in Europe, and particularly in Germany, being one of the leading countries in this area, think of wind, that required a grid. Without the European grid, I would argue that would have not been possible. So one has to exchange large amounts of energy from the places where they're generated to the places where we need them. Urban centers definitely need energy in terms of grids. And I think one could argue we need two types of grids. We need grid for energy gases. Today that's natural gas, that's solid fossil in nature. But in the far future, and my colleague Professor Jürgen Schmidt has discussed this issue in the episode number 2, in the future we might be producing synthetic gases from renewables, including renewables that could be the methane, the main constituent of natural gas, but could be also hydrogen. But in any case, you would need a grid for that, a grid of pipelines. And then for electricity, we need a grid. And right now, Asia does not have a grid that covers the whole Asia. North America does, US, but it's not as integrated as the European one. And we would need these kind of systems. The higher the share of renewables is, I would say there are two concurrent developments. One is on-site generation, very close to the consumption, that's local, so you need local systems. And then we need these larger systems to bring offshore wind and remote solar energy to the consumption centers. And I think another concept are the smart grids. So they have to be super and they have to be smart in order to make this transformation possible.
Okay, yes. I liked this picture of the house we had where we saw how it looked before and then after when it had been retrofitted, and it was 90% more efficient, I think it said. Is this possible, hypothetically, to happen to all houses or all buildings?
I would argue that it's not just possible, also desirable. But again, we come to the first question, the capital investment. It is exactly the same situation. You have upfront investment in insulation to retrofit the house. That way you improve the thermal integrity of the house. It's beneficial for both heating and cooling, so it's applicable to temperate climates, but also to cold climates, thereby reducing energy needs to negligible amounts. That requires capital, and this is yet another problem, is that very often today people who have to put the upfront capital are not necessarily people who benefit from it. So the person who benefits from the lower energy bill is the society and the tenant, but that's not necessarily the person who owns the house. We have the same dilemma in public buildings. So these are the huge opportunities, but we need institutional arrangements. One of the notions are energy service companies that could mediate between the owners and the people who rent by providing this capital outlay to lower the cost in the long run, because the cost would be lowered. So in principle, it's possible everywhere, but we need a capital for it. It's doable, and maybe we would not do 90% reduction, like in the ideal case I've shown. Maybe we go to 50% reduction. That makes it even more affordable and more profitable in the long run.
Yes, at the end of the day, it's an investment then.
It's an investment decision, but it's with a social benefit, so we need the right institutional arrangements.
Yes. Okay, and talking about carbon capture and storage, this is something that you mentioned. I was wondering where it could be stored and whether it would be dangerous to do this, if this is a desirable path to go down.
Yeah, this is a difficult question to answer properly. I mean, just in general, I'm not aware of any technologies that are not dangerous. I think we always have some inherent dangers. But carbon capture and storage is perhaps more problematic than any other technologies we've been dealing with. The reason being manifold. One of the dangers of storage is that we might have spontaneous leakage. Now, if the leakage is slow and prolonged, we have ruined the strategy because the CO2 went up in the atmosphere again, and we have gone through the investments through building the storage capacities for nothing. Basically, we would be wasting things because the climate signal would be back there, but CO2 ended up in the atmosphere. But that's for creeping leakages. What one can imagine more rapid leakage, and because CO2 is heavier than air, it would hug the ground. And if one were there, it could be dangerous because there would be a lack of oxygen. In mining, miners would always, to a coal mine, take a canary bird in the old days to make sure that there is no methane or CO2, that one can actually breathe. This would be an inherent problem. So that's another danger. And the third, I would say, category of dangers is changing the strata under the earth. We do that with conventional oil and gas and coal mining. Adding carbon dioxide under the ground could have the same tectonic effects. So that's a third class of dangers. And this is why many people oppose the idea of storing it in the underground aquifers on land. One option might be under the ocean, in the sea, below the seabed in the ocean. Sleipner platform in North Sea does that, and that might be one of the technologies. For the interim solution, the best would be to avoid emissions altogether. Then we wouldn't need the option.
Yes, so better not to use it at all. I have one last question for you about the 2011 Flagship Report that was published in that year in England. Obviously, in English, I mean. So that was very recent, and I was wondering if you think we've made enough progress so far and if we're going in the right direction.
The Flagship Report argues that there are agents of change already today, that things are happening in the direction of achieving a sustainable future. But one has to say it is kind of embryonic. It's the beginning, and it's a long haul. We will need decades to achieve the transformation. The sooner we start, the better. I'm afraid if we postpone it, it might be too late. And so it is essential to nurture these agents of change. That means, affecting lifestyles, human behavior, to right incentives. I'm more optimistic about the private sector. I think that once the private sector has the right signals, then the change can occur relatively rapidly toward more sustainable technologies. So we will need a number of processes, and this is why the Flagship Report asks for a proactive state. It asks for a new social contract to go in that direction, to support and nurture the elements of change, the agents of change that are already occurring, and induce others to accept this innovation, to accept the new lifestyle, to accept the new technologies that would bring the sustainable societies in the future.
Okay, yes, of course, and we have to stay very positive about everything. And yes, those were all the questions that I had, and thank you very much for your insights. They're very interesting, and I hope that the students enjoyed listening to them. And that was it. Thank you very much.
Thank you for the interview.